Students, today we are going to take the next part of Pythagoras, which is applications of Pythagoras. In that applications, we know Pythagoras is always applied in right angle triangle only. But now we can apply in acute angle triangle as well as in obtuse angle triangle also. How we can apply? See first here. We know what is acute angle triangle, in which all the angles are if less than 90 degrees, then we can say it is what? Acute angle triangle. Okay, now see here, just try to observe here. See, this is acute angle triangle, in which all the angles are what? Less than 90 degrees. Suppose I take here the name of the triangle is ABC here. Okay, in this particular triangle, we are going to draw one perpendicular from any vertex. I will apply here in this triangle from A. We can draw one perpendicular, which is will take as an area. Okay, now that one we have to use, and by using that one we can apply that Pythagoras. So how we can get that one, we'll see, we'll discuss in this proof part. But before that one, what is there after applying Pythagoras? See here, I'll first write given part. What is given? In triangle ABC, in which AM is perpendicular to BC, where M is lies in between B dash, M dash, C. Okay, now look here, how I can apply here. Okay, see here. Here, the base angles both are what? Acute angle. Okay, so by that property, look here, opposite to this angle, which is AC here, and opposite to this angle, both are acute angle. So opposite to this one is AB here. Both in terms of we can write here. What is that? Look here. First, AB square, this one. Okay, which is equal to remaining two side squares and their sum. What we get here? AC square plus this base BC square. Base is also of same triangle, side of that same triangle. Okay, here minus choice of base into. Now look here, the very important part is that here it is AB. Okay, now base is divided in two parts. First one is BM and second is MC. Okay, now here we'll wrote here AB. So out of these two parts, which is the remote part? Remote means what? It is we can say here it is very longer and it is very nearer. Okay, we have to take here longer. Okay, now look here, AB is there, we have to take here MC. If we take here AC, then we have to take here BM. Why? Because it is just longer than this MC. Okay, now we are going to take here only AB. Now see here, AB square is equal to AC square plus BC square minus 2BC into, because of we wrote AB here, we have to write here MC. Okay, like this one. Okay, now one more option is there. As like AB square, no, where we can take here AC square. Why? Because there are two angles at acute angle. This is the property which is acute angle triangles Pythagoras. Because of that reason, we have to take here both acute angles of base. Okay, now here we can write here AC square. Now we can write here. Here we wrote AC square. So which are the two remaining two sides of that triangle here? AB square and BC square. Then sum. Here also minus because it is acute angle. Choice of, again we have to write BC as a base into which part of base we can take here which is longer. Okay, this is the BM of AC. We cannot take MC here. Why? Because it is just attached here. Okay, adjacent here, and this BM is just longer than this MC. Okay, here BM. Longer in the sense we can apply here that remote part which is just what you can say here. This is just nearer. We cannot take nearer. So, okay, which is not nearer, that one is nothing but here BM of that AC here. Okay, now this part we are going to prove here. Understand? Look at how we can prove here. This is very important part. If you observe here, there are two triangles which are right angle triangles. See here, AMB and ANC. Actually, the bigger one is a triangle, but which is not a right angle triangle. As we know, it is what? Acute angle triangle. Here we can write here, in the given part only we can write here, angle B. On all the angles, we can say angle A, angle C, angle B, and angle C are less than 90 degrees. Okay, means what? All of them are what? Acute angle. Okay, now let's see in the proof part. What is that? We are going to see here in first right angle triangle. Apply Pythagoras. In right angle triangle, which one? A and B. Use Pythagoras. What you can say here now? AB square, which is hypotenuse, is equal to AM square plus BM square. It is correct? This is by Pythagoras. Okay. Now, if you observe here, after applying here also Pythagoras, we can get here this AM, which is a common side of both one. So we can write both the Pythagoras in terms of AM square. And if one side is AM square, we can equate the remaining side. Okay? That is why I'll write this one in the form of common side, which is AM square. We can write here this side only AM square. I'll take this BM square to this side. So AB square minus BM square. Understand? This is from 1. And similarly, we can write in another right angle triangle, which is AMC. Okay, here also apply the same thing. Just try to apply Pythagoras. What you can get here? AC square is equal to AM square plus MC square. Is it okay? Now, this is by, again, Pythagoras. Okay. Now again this one write in the form of common side, which is AM, and this MC comes this side, that will minus MC square. This is from 3. Now just try to look here in second step and fourth step, this AM is there. Okay, so we can equate these two are same. That is why this side, then other side is the same. This is their LHS. Because of RHS same, we can write LHS same. So AB square, look here, this is important part, is equal to what? AC square minus MC square. See here, I am going to prove this one and this one we can write similarly. Look here, if you want to write AB square and you want to prove that AB square, then this AB square minus BM square write first. If you want AC square, then this particular part write this side and that one to that side. Understand? Okay, now this is from second and fourth step. See here, this BM square goes to that side because we need this side only AB square. See first, AC square minus MC square plus BM square. This is from fifth step. Now the next part just try to observe here. What is that? AB square. We need AC square. Yes. And here, this MC square, BM square, we need MC square. That means this BM we don't need. That BM we can write in different form. Look here, this is BM. How we can write? BM is nothing but BC minus MC. Is it correct? Because of this between this B dash M dash C, we need BM only. That means BC minus MC, which will get here BM. So here we'll write here AB square is equal to AC square minus MC square. This is the BM, which we can write BC minus MC bracket square. By using betweenness, this is from 6 and B dash M dash C. Okay, now we can write that one in the form of A minus B bracket square. See here, AB square is equal to AC square minus MC square. This one we can write in the form of A square minus 2AB plus B square. Okay, BC square minus 2AB means BC into MC plus MC square. This is from 7th step. Now just try to observe what we'll get here. Here it is minus mc square, here it is plus mc square. Both getting cancelled. Now what is the remaining part? Look here, ab square is equal to ac square plus bc square minus 2bc into mc. This is the from 8th step, that is our proof. Look here. Okay, if you want to prove AC square, very easy part, just write this 4th step, write first in LHS and then write the 2nd step, write in LHS. And then this MC square goes to that side, finish. Very similar way, you can also write the proof of that part also. Okay, very important part. Understand friends? Now friends, we'll take same Pythagoras in obtuse angle triangle. Okay, see now. This is obtuse angle triangle. I'll draw. What is obtuse angle triangle? We know here. One of the angle of the triangle is greater than 90 degrees. Okay, that one is called as obtuse angle triangle. Now see here. Again I'll write the same thing, ABC here. Okay. Now here we have to extend. Why we have to extend here? Because we need perpendicular. That one goes in outside. That is why we have to extend the base. Look here. This is the perpendicular. Again we'll write here AM. Okay. Now I'll write the given part. Okay. Now here just one angle only, obtuse angle, which is this one. That means we can take one time only a square. Here in acute angle triangle there are the base angles, both are acute. Okay, that is why we can write it two times. There are two options here. But here it is only one angle which is obtuse angle. That is why AC square only will come. Okay, now look at given in triangle ABC, angle ABC which is of 90 degrees, more than 90 degrees. Okay, now here AM which is perpendicular to BC, but M lies before BC. That means M dash, B dash, C. This much part is in given part. Okay, now what we have to prove, just listen and observe very carefully. What is that? AC square. AC square is equal to remaining two sides means what? AB and BC. We'll write here this side AB square plus BC square. In that acute angle triangle, we wrote minus, here we have write plus. It is only trick to remember. So, plus, twice of base is BC only. Okay, now, which is that remote part of that base? Here it is MB, BC. Or MC. Yes, see here. That one, MC is just connected. It is adjacent. BC is also connected. Only MB is a part which is just not nearer to that AC. So we have to take that part, which is MB. Okay, let's see. This is just remember. How to remember? That is only the trick purpose only. Okay, now look here. Now tell me, very similar as like we proved in that acute angle triangle here also. Look here in this figure, how many triangles are there? We know 3 triangles are there. Out of the 3 triangles, 2 triangles are what? Right angle triangle. Okay, we'll apply one by one. See here, the first one. Proof. In right angled triangle. Which one we have to take? Take AMB first. Okay, as you wish. AMB. Apply the same thing. AB square is equal to AM square plus MB square. This is by Pythagoras. Okay friends. Now that one again we'll write in the form of common side, which is AM here. So keep this AM square here only. Take MB square to this side. AB square minus MB square. This is from 1. Very similar. And in right angled triangle, other one. Which one? AMC, bigger one. Look here, AMC. Okay, now here also apply the same thing. But you can write here, hypotenuse is what? AC square is equal to AM square plus MC square by Pythagoras. Okay now? Look here. AC square is equal to AM square plus MC square. This is Pythagoras in bigger triangle. Okay. Now, again this one will write in the form of AM square only. Take that MC square to this side. Look here friends. Very similar. Look here. In these four steps as it is from that acute angles property. Here also it is. This is from 3. Now, in the next part also we have to equate this m square. So this second and fourth step we are going to equate. But we need here AC square. That means here is AC square. So this part we will write first. Okay. Therefore, AC square minus MC square is equal to AB square minus MB square. Okay friends? This is from second and fourth step. Again take this MC square also that side. This AC square is equal to AB square minus MB square plus MC square. Okay? Write in it. Okay, this is from fifth step. Now, look here. AB square we need. Okay. Here BC square, BC MB is there. MB we need. That means we don't need this MC, right? In betweenness form. What is MC here? This is full, which is nothing but MB plus BC. We can write by betweenness. Okay? See here. AC square is equal to AB square minus MB square. This is nothing but MB plus BC bracket square. This is from 6th and M dash betweenness. M dash B dash C. Okay? Because of that MC means MB plus BC. Now expand in the formula A plus B bracket square. Okay? Here AC square which is equal to AB square minus MB square plus. What will we get here? MB square plus choice of MB into BC plus BC square. This is the expansion of that bracket. This is from 7th step. If you observe here, minus MB square plus MB square getting cancelled. Finished? The remaining part is nothing but the proof part. Look how easy it is. This is the 9th step. AC square is equal to AB square. Right? First BC square. Okay? And then plus choice of MB-BC, but I'll write choice of BC-MB in this form. Okay, we can keep as it is also. Plus choice of BC, MB. This is from 8th step. Like this, we can prove the Pythagoras in obtuse angle triangle also. But now, these acute and obtuse angle property, we have to apply both in the one more property, which is again very, very important property of this topic, which is called as Apollonius Theorem. So just try to remember how we can apply this one. Without proving we know how to write. The trick just try to remember. Just the far away side we have to take from whichever you have to take the side. Okay? Friends, by using these two properties, we are going to take the new theorem, which is very important one, Apollonius Theorem. What is this? This has no statement actually. Only there is the two words are very important to apply this Apollonius Theorem. One is midpoint or median. Whenever in a triangle midpoint is there or median is there, then 90% times, more than 90% times we have to apply Apollonius Theorem. See here how we can prove this part. Okay? Look here. What we need here, first, this is the given triangle. Okay? Here it is the median. Median means you know here. Okay? Median means segment joining any vertex of triangle and midpoint of opposite side of that vertex is called as median. Okay? Here this is the midpoint here. Okay, right here A, B, C. Here it is one triangle. AM is a median means and is midpoint of BC. Okay? C. I'll write given part. In this particular triangle, in triangle ABC, you can write AM is a median, or you can get AM is equal to MC. This much is only the given part. Okay. Now, what we have to prove here? We have to prove. This is very important. Just remember, this is very, very important. Okay. The median came from which vertex here? A. Okay. Now, about this vertex A, there are two adjacent sides of that triangle. Which are the two adjacent sides here? AB and AC. We have to take sum of squares of these two sides. Means what? AB square plus AC square, which is equal to sum of twice of square of the median here. Means what? Twice of AM square. Okay? Now remember here, twice of AM square is not AM square, and it's twice. Remember. Plus, now here, there are two parts of that base here. You can take any one part of that, either BM or MC, because both are same. So I'll take here BM, twice of BM square. Okay, twice of BM square. This is we have to prove. Okay, understand what I'm writing here? Okay, look here. Just remember, because we are going to use this particular part directly in some examples whenever they're given to us in this form, we have to apply Apollonius. Okay, that time you have to write this one directly. Just remember, I will tell you again, look here. Square of AB square plus AC square is equal to twice of median square, which is the AM here, and here twice of BM square, which is the half of BC, which is the base here. You can take MC also. Okay? Look here. Now, how we are going to write this one? Proof. See here. I'll split it two parts here. Look here. This AM, ABM. Just look here. ABM, which is the acute angle triangle. Now, this side triangle, which is obtuse angle triangle. Understand? And both have same height. I'll draw the construction. What is that construction? I'll draw here. This is what I'll take here like AD, which is perpendicular. See here, AD perpendicular to BC. Where is D? This is B dash, D dash, M dash, C. Like this. Okay? Now, this is the AD, which is the same, there is common height of these two triangles. That one we discussed in similarity. Yes, here also the same thing. Now look here. Here, because of it is acute angle triangle, I write the names also. ABM. This is obtuse angle triangle. AMC. You can apply here. This is perpendicular. Here it is also perpendicular. It is D here, B here. And in this particular part we have to apply acute angle triangles Pythagoras, and this particular part you can apply obtuse angle triangles Pythagoras. Okay, see first. In triangle, or you may write here in acute angled triangle. Which one? ABM. Is it correct? Okay, now we can apply Pythagoras here. Just try to remember how we can apply. We need what? AB square. So we can get here AM square also. But here we need AB square only. AB square is equal to remaining sides AM square plus BM square. Okay? In acute angle triangle, right? That minus. Okay, minus. And base is what? BM. But twice. BM into the remote part. Means very far away part. Means AB is there, because of that reason you have to take here D. Okay, now we can write here, this is by Pythagoras in acute angled triangle. Okay, Pythagoras in acute angle triangle. Okay, now and in obtuse angled triangle. Which one? I'll take here AMC. Okay, now here also very similar, just what we proved in the previous property. Here it is. This is what? AC square. Remember how can write this one? AC square is equal to remaining two sides AM square plus MC square. But in obtuse angle triangle we can write here plus choice of base is what? Here MC is only the base. Remember, into. Now here because we take here AC, we have to take this far away part which is DM. Okay, it is perpendicular. So DM only. MC into DM. Here also we will write the reason by Pythagoras in obtuse angled triangle. Okay, now look here. What we are going to make here? We need AB square and AC square. There is some we need. By adding these two, so AB square plus AC square. That's also we have to add only AM square plus BM square minus choice of BM into DM plus this one AM square plus MC square plus choice of MC DM. What will write here? By adding 1 and 2 here. We can write here by adding 1 and 2 here. Okay, now just look here. It is very important one. Remember friends. Here AM square twice of that one. Okay, AB square plus AC square twice of AM square. It is AM square. But now just look here. Okay, instead of adding this part, just listen very carefully. We know what BM and MC both these are set. Okay, that part I will write here now. Okay, see that. But BM and MC both these are same. It is in given part. Okay, out of these two, which part we need here? We take BM. So wherever MC at that time, replace that MC by BM. Okay, look here. What will come? AB square plus AC square. Only part remember is what? Replace MC by BM. You can replace BM by MC also. Okay, why? We'll take here BM square. That is why we have to replace MC. Okay, look here. AM square keep as it is. This BM, we need BM, no? Keep BM also as it is. Minus choice of BM into DM. What is DM? Okay, keep as it is DM. No problem. Plus AM square. Now MC, we don't need MC. Replace that MC by BM. Square is there, okay? Twice of again MC, write BM into DM. This is from 3 and 4. Okay, from 3 and 4. Now, just try to observe. What is that? Minus choice BM into DM plus choice BM into DM. This particular part getting cancelled here. Okay, now what is the remaining part? Try to observe here. AM square, we'll write here twice of AM square plus BM square, write twice of BM square. This is from 5th step and that is our proof. See friends, it is very important. The proof is not important, but how to apply this Apollonius in example is very, very important. Sometimes when the students were applying this property, at that time, if instead of taking this BM or MC, if they used DC, then their whole example becomes wrong. Okay, so try to remember when and how we can apply. Okay, here BM and MC, both these are what? Half of DC. If they are given to us DC, then make the half and try to use that one. Okay, this is very, very important. Understand?